So now in this video I'm going to explain about the next instruction, which is ANI. The meaning of that, and immediate with accumulator. So here their opcode for this instruction is ANI. Their opcode for this instruction is ANI, and their operand will be 8-bit data here. Why we are taking only 8-bit data? Because this is going to perform the logical ANDing operation with the content of accumulator. So the size of the accumulator is only 8-bit. The size of the accumulator register is only 8-bit. So we can perform the operation with the similar size of data. So that is the reason we are taking here as a immediate data of 8-bit. So we can understand their operation in detail with the example. So let's say, for example, we are writing here as a ANI 97H. 97H. So here, before execution of this instruction, I am assuming that this accumulator content is here as a A3H, and whatever we are taking this data, so this data is 97H. So this is before execution of this instruction. Now how it will perform this operation? So here let's see, this A is equal to A3H, and this data here we are taking as a 97H. So their binary pattern will be written as like this. A will be, A means it is 10. So this can be written here as a 1010, and this 3 can be written here as a 0011, and this 9 can be written here as a 1001, and 7 can be written here 0111. So now, as per the previous operation, whatever I had explained as an ANDing operation, so here their output will be what? That 1 ANDed with 1. So this both is 1, so their output will be 1. From the second stage also, their output will be 1. From third stage, it will be 0 ANDed with 1, it will be 0. From the fourth stage, it will be 0. From the fifth stage, it will be 0. From the sixth stage, it will be 0. From the seventh stage, both the bits are 0, so their output will be 0. From the eighth stage, which is the last stage here, so 1 ANDed with 1, it means their output will be 1 here. So we got this result here, and this result will be 8, and this will be 3. So this 83H will be stored into accumulator. So this will be stored into accumulator. So after execution of this instruction, what will be the data? So after execution of this instruction, this accumulator content will be 83H, and data will be as it is. So data will be 97H, whatever we had taken here. So only after the operation, this accumulator content is going to be modified as per the result obtained. And as per the previously explained that ANA, so the effect over the flag will be same as like previous instruction. So here this sign 0 parity, how it will be changing? So here we can write sign 0 parity, and this side it will be auxiliary carry, this side it will be carry. So here we will see that this sign flag is 1. This is the sign flag here. So sign flag will be 1, and the result is non-zero. So this 0 flag will be 0 itself, and the number of ones available is odd here. So due to that reason, this will be performing odd parity. So parity bit will be 0 here. And as I told previously also that auxiliary carry in this ANDing instruction, it will be always set, and carry, this carry will be reset. So this carry flag will be reset, and auxiliary carry, this will be set. So this will be the impact over this flag. So in the note here also we can write down. In the note we can write down here that sign 0 parity flags will change as per the result, but auxiliary carry, it will be always reset, and this auxiliary carry will be set and carry flag will be reset here. So these things you must have to take care while using this ANDing instruction as a ANI. Now we'll talk about their size. So as we had taken this example, ANI 97H. So the first byte by default will be their opcode as a ANI, and the second byte will be their operand, 8-bit operand as a 97H. So this will be occupying two memory location, or as like we can say that here this instruction consists of English alphabet and 8-bit of immediate data. So by default it will occupy two memory location. So here the size in terms of byte, it will be 2 byte here. Now this will be 2 byte here. Now the machine cycle, so by default the first operation will be opcode fetch. Then this opcode fetch, during the opcode fetch, that microprocessor is knowing that their operand is 8-bit immediate data which we need to read from the memory. So accumulator is there inside the processor, so that is not required further machine cycle. And here as a second machine cycle, it is going to read this 8-bit of immediate data from the memory. So by default the first operation will be opcode fetch and second operation will be memory read, because accumulator is already inside the processor, their ALU unit where this operation perform is already inside the processor, so they need only the second operand from the memory apart from this opcode fetch. So that is the reason it is required two machine cycles here, and these machine cycles can be called as opcode fetch plus memory read. So by default we know that for this opcode fetch operation it is required 4 T state, and for the memory read it is taking 3 T state. So this is 4, this is 3. So 4 plus 3, total number of T states required for the execution of this instruction is 7 T states. So I hope you understand the operation of this ANI instruction, how it is operating and what is their impact over the flags. So again I am recalling you that the major point is this auxiliary carry should be set and this carry should be reset. So these things you must have to keep in mind while using this instruction here. So I hope you understand this instruction with much of clarity in the better way. Thank you.